Now, the next question we're going to go into now says, a vehicle on a curved part of a road that is 8 meters in length has a radius of 8 meters as well, goes with a speed of 1.5 meters. A speed of 1.5 meters per second, that is the velocity. A speed of 1.5 meters per second goes with the speed. Calculate the total acceleration of the vehicle at the starting and the end of the curve and the time of the motion on the 8 meters curved path. If the vehicle gets out of the curved path with a speed of 1.2 meters per second. So it's simple, the same way we have been doing normal acceleration, because the velocity that used to enter the curved road was 1.5 meters per second, and the radius is 8 meters. So at the inception of the journey, normal acceleration is equal to 1.5 squared over 8. 1.5 squared over 8, which is 0.28, which is equal to 0.281 meters per second. Per second squared. That is the normal acceleration at the inception of the journey. To get the tangential acceleration, we look at it. We have in the question, we have the distance traveled in the question. We have the velocity with which it started, which is 1.5. We have the velocity with which it ended, which is 1.2. So that means the third equation, I use the third equation, which is v squared is equal to u squared plus 2as. 2as. If you go to where I prove the equation of motion, this is the third equation of motion. So in it, we have 1.2, that is the velocity at the end of the journey. Then 1.5, this. Then the distance, 8 meters is the distance traveled. So we can get our acceleration, that is tangential acceleration. We can get from here, we can get tangential acceleration. If we put everything to, we have 1.2 squared is equal to 1.5 squared. Then minus, because it was decelerated, from 1.5 to 1.2, that means the velocity reduced. Minus 2 times the acceleration we're looking for times distance, that is 2 times 8, which is 16a. So from here, a is equal to 1.5 squared minus 1.2 squared over 1.5 squared minus 1.2 squared over 16. That is the tangential acceleration, which I got here to be equal to 0.051. This is equal to 0.051 meters per second. That is tangential acceleration. Because earlier we got the normal acceleration. Now we're going to tangential acceleration. So at the beginning, we can get total acceleration now at the beginning of the journey. So total acceleration at the beginning of journey will be the vectorial summation of the two, which is total acceleration at the beginning of the journey, total acceleration, total A acceleration. So the square root 0.28 squared plus 0.051 squared. The one we did earlier. That's total acceleration at the inception of the journey, which I got to be that tangential acceleration is gotten to be 0.286. Is what is 0.286 meters per second squared. That is the total acceleration. Total acceleration at the inception of the journey. So now, towards the end of the journey, the normal acceleration will be towards the end is equal to 1.2 squared over 8. 1.2 square, which I got to be 0.18. 0.18 meters per second square. So to get the total acceleration, the same way, to get this total acceleration, because we already have the tangential acceleration, we have the square root of total acceleration, total acceleration is equal to the square root of 0. That is the 0.18 squared plus 0.051 squared. That will give total at the end of the journey, which I got to be 0.187. 0.187 meters per second squared. So that is the total. That's as simple as that. So let me now say the question. The question says a vehicle on a curved part of a road. A vehicle on a curved part of a road of 8 meters length. The vehicle on the curved part of a road that is 8 meters in length has a radius of 8 meters. The vehicle goes with a speed of 1.5 meters per second. That's at the inception. Now calculate the total acceleration of the vehicle at the starting and the ending of the curved part. At the starting and ending of the curved part. At the starting and the ending of the curved part. At the starting and ending of the curved part. And the time of motion on the 8 meters curved part. If the vehicle gets off to the curve part of the at this speed. So that is that. Because in the total acceleration that the vehicle used to do the whole journey, we got the total acceleration, the acceleration at the inception and the acceleration at the beginning. If we have this, we have that velocity is equal to acceleration times time. So if we now divide any of the acceleration, any of the velocity with time, or with acceleration, there's velocity with acceleration, we get the time. So if we want the first one, we divide the velocity, which in this case, the velocity will be at the beginning, 1.5, divided by the acceleration, which is 0.286. We get the time at that time. If we come to the end, we have 1.2 divided by 0.18. So we get the time. So that's the solution to the problem as given here. Thank you very much.